Hi guys, welcome back to my channel. My name is Jag, and for those of you who are new, this channel is all about math and science at the high school level, and it includes also grade 11 and 12 chemistry and biology. If you have any questions, feel free to just email me at jaggy5patel@gmail.com. I want to make sure everyone is excelling at all the courses that they are taking at the high school level. Alright, so with that, let's get started. Today's class is going to be Chemistry 11. We're going to cover synthesis and decomposition reactions. So this might be basically a review. It was covered last year in grade 10 science in the chemistry section. Okay, so let's dive right in here. And we're going to try this example I wrote down on the board. Okay, so I have iron plus oxygen. Okay, and usually the teacher will write the equations like this. You should be able to predict what the products are going to be. Okay, so I'm going to write the general form of the synthesis reaction. Okay, and some students prefer to basically look at these letters, and it's easier for them to understand how to form the product. Okay, so it's going to be A plus B, and it's forming AB. So just like that. Okay, so just applying the general formula here, let's look at the example that I wrote on the board. So I have to remember that iron is a transition metal. Okay, so it has two charges. It has 2 plus and it can also be 3 plus. Usually the teacher will indicate which charge to use in this case. And what we're going to use is Fe3 plus. So I'm going to write it on the bottom here. Okay, so the charge for iron is 3 plus and oxygen is always 2 minus. And again, make sure you're checking in your periodic table and use a periodic table that gives you the charges for all of the elements. Okay, we're going to use the crossover method here, so I'm going to draw arrows, so just so you can see it, just like that. And what we're forming as the product is going to be iron oxide. Make sure you are crossing the charges to the opposite side. Don't keep them on the same side here. Okay, so the product that's formed here is Fe2, okay, O3. So this is my equation. Okay, I was able to just predict what the product is that's forming in this synthesis reaction. This reaction is actually very common. Okay, iron basically rusts over time, and this is due to its reaction with oxygen. Okay, now right after you write out the equation, what is it I should be doing? Should I just leave it like this or what? So remember, as soon as you write the equation, I have to make sure it is balanced. Okay, so I'm going to look over here. I see that there are 3 oxygens on the product side. There are only 2 oxygens on the reactant side. And I want to pick like an even number, okay, to make sure that I can balance it. So I'm going to put 3 in front of the oxygen, okay? So I'm going to do 3 times 2. So I know there are 6 oxygens on the reactant side. And the only way I can balance it on the product side is by putting a 2 in front. Again, the coefficients can only be put in front of the compounds. Okay, so if you look here, I have 2 times 3. There are 6 oxygens, okay, on the product side. All right, and then it also applies for the iron. So the iron is going to be 2 times 2. So there are 4 iron atoms on the product side. So I'm going to put a 4 in front of the iron that's on the reactant side. Okay, so at the end, this is the balanced equation. Okay, I have 4 atoms of iron on both sides, and I have 6 atoms of oxygen on both sides. All right, again, if you do get a little confused with the balancing the equations, I would draw out the table, and if you want to check that out, you can check out one of my other videos, and it's basically on balancing equations, and that will really help you out. I would keep drawing out the table until I get really good at balancing the equations, and at that point you will just be able to put the numbers in front and you'll be able to see whether or not the equation is balanced. Are there any questions here? Alright, yeah, so that looks good. Okay, with that, let's pick an example, okay, from the textbook. So again, in the Chemistry 11 textbook, okay, there will be a lot of practice questions, okay, that you can try in this section. So I'm going to pick one of the questions from the review here. So let's try this one. Okay, so this is potassium plus bromine. So like this, all right. And again, remember in the synthesis reactions, only one product is formed. That doesn't mean that the reactants have to be elements, okay? It can also be one element, and I'm combining it with one compound, and then it's forming one product altogether, okay? That can also be a common reaction. So here I have potassium and bromine, okay? I'm just going to combine them together, so I'm going to put KBr, okay? Right when you write out the product, I have to make sure I check my periodic table here, and I'm checking for the charges so I can cross the charges over. So if you look in the periodic table, potassium, okay, is 1 plus, and bromine is 1 minus, okay? So when I see that the charges are the same here, I don't need to bother crossing it over, okay? These are just going to cross out by themselves. So just like in math, okay, I'm crossing out the 1 plus and the 1 minus. Okay, and I'm only left with KBr. So this is my product that I just predicted right now, okay? I have to make sure that it is balanced, okay? So what I'm going to do is I'm looking at the bromine on the reactant side. I can see that there are 2 bromine atoms, okay? And the only way I can balance it on the product side is by putting a 2 in front. So again, remember when you're putting the number in front here of the compound, I now have 2 bromine, but I also have 2 potassium atoms. So on the reactant side, I'm going to put a 2 in front of the potassium, okay? So now there are 2 potassium atoms on both sides of the equation, and I have 2 bromine atoms on both sides of the equation, okay? This is the balanced equation for this reaction, okay, which is a synthesis reaction. And there will be questions also where the teacher is going to go through all the types of reactions, and then it will just be like you identifying what kind of reaction it is. This is a synthesis reaction. Okay, so with that, let's move on. I'm going to take this off. Alright, so we're going to take another example from the textbook. So we're going to go to the decomposition reactions. So now a decomposition reaction is just the opposite of a synthesis reaction. Okay, I'm going to start off with one product, and the product is going to break down into its elements. Let's take a look at the general equation. It's going to be like this. I have AB, okay, which is one product. It's going to break down into its elements, okay? Or it can break down into like an element and a compound. So that doesn't really matter, okay? How I know it's a decomposition reaction is I'm going to start off with only one reactant, okay? So with that, let's try an example. So I'm going to pick one here from the textbook. Let's try a simple one. So this is HI, okay, which is hydrogen iodide, okay? I'm not going to put the states here. I want us to just take a look at the type of reactions. All right, and again, the teacher will ask you to predict what the products are. HI is going to break into the hydrogen, okay? Then it's also going to break down into the iodine, which is I2. So remember, I can't just write H plus I, and that's what it broke down into, okay? We have to make sure we remember that upside down L in the periodic table. Hydrogen and iodine are diatomic molecules. I have to put a 2 right beside it, okay? And again, this is the most stable form of these elements in the environment, okay? So make sure you're always putting a 2 there. So let's try balancing this out, okay? I'm not going to draw the table because this looks like a really simple reaction. I notice on the product side, I have 2 hydrogen atoms, okay? I also have 2 iodine atoms. And on this side, the only way for the reactant side, I can only balance it by putting a 2 in front of the hydrogen iodide, okay? And this shows that I have 2 hydrogen atoms on the reactant side, and now there are 2 iodine atoms on the reactant side, okay? And this is the balanced equation for this chemical reaction. Make sure you're always just counting the atoms, okay? And make sure that you have the same number of atoms for each element on both sides of the equation. All right? This is the decomposition reaction. Again, remember, it is just the opposite of the synthesis reaction. This is the general equation or the general form of this reaction. All right, so if there are no questions, that brings this video to an end. This video just covered the synthesis and the decomposition reactions. And if you like the video, just hit on the like button below. Make sure you're subscribing to the channel. Thanks for watching, and I'll see everyone next time. Bye.